Hello and welcome to Kerbal Space Program with me, Taki 117. So, here we are sitting on the pad with another satellite ready to go. So, let's begin our countdown. Launching in 10, 9, 8, 7, 6, 5. Go for me. We have start. 2, 1. Ignition and liftoff of the Earth Scanner satellite. The satellite is designed to scan the relative inclinations of the planet. As well as provide some much needed mapping services. So here we go. We are actually going to put this one on the correct orbit to begin with. We're going to go north here. Other way. Alright, there we go. Oh dear. Looks like we are potentially going to lose this satellite. That is not good. Not good at all. We are falling. This is not good. This is not good. Kicked up the engines to try and get us a little bit of control. Seems to be working a little bit. Fortunately, it might be too little, too late at this point. Or not, we are climbing. We are in fact climbing. Go ahead and drop boosters. Oh dear. Oh dear, oh dear, oh dear. This mission has gone from bad to worse. Fortunately, it looks like we still have plenty of Delta V. We are still mostly on track. Unfortunately, my payload is now not protected by my fairing. Our flight path is a little steeper than I would like. To save this mission. Yes, we have saved this mission. Assuming my satellite doesn't blow up, because that would be, that would be bad. am trying to pull my prograde marker to the left to get on in a polar orbit. However, I should be pretty good as far as that is concerned. You can see my orbit here shifting. And yes, I have somehow managed to miraculously save this mission. It's a real testament to how much Delta V this rocket has. To be able to undergo such a large, almost catastrophic failure and still manage to not only make orbit, but to successfully perform a rather severe plane change maneuver is incredible. Real life rockets don't do that. They can't. As soon as something like that goes wrong, NASA blows it up because, you know, the safety of the people is paramount. Alright, so as we're flying here, I'm going to go ahead and extend these panels. And I'm also going to activate my antenna, both of them, so that I can maximize my communication. I'm going to drop my main lifter stage here. Just like that. Now I'm going to change both my apoapsis and periapsis to 250 kilometers. So right now what I'm doing is I'm fiddling around with my burn time. There we go. So after 200 seconds, which is a little over 3 minutes, I'm going to adjust both my apoapsis and my periapsis to be about 250 kilometers in altitude. Go ahead and execute that node. And then I'm going to perform a plane change maneuver. See my solar panels tracking the sun there. Once I complete that, I am going to perform a plane change maneuver so that I can get in a perfect polar orbit, so that my scanner will scan the entire planet eventually. So here we go. Beautiful picture of the Earth there. Look at the aurora right there. Now, the aurora is caused by charged particles hitting the Earth's magnetic sphere and causing the disruption of the magnetic field lines interacting with the atmosphere. And if you're on the ground, it's very beautiful to watch. And also very beautiful from space as well. But unfortunately, the graphic limitations of Kerbal Space Program just don't do them justice. You really need to go onto Google and look for like International Space Station Aurora, or Aurora Borealis or something like that, to really get an appreciation of what these things look like. What do you got? There's that Venus over there. Now, as you can see, as I'm making this burn, my apoapsis is coming down and my periapsis is going up. So, and this is really what's happening if you burn towards the planet trying to deorbit. Yes, you will eventually get there. Unfortunately, it's going to take you a lot more delta V than just turning retrograde and firing your engine and slowing down. With space travel, you want gravity to do most of the work for you. The more that you can have gravity take over, the less fuel you have to burn. What is my current altitude? Overshot my target just a little bit, but that's okay. I'm only off by like 500 meters. I think I can live with that. We're going to point a little positive again. Oh yeah, that's right. I need to adjust my inclination to 0 degrees. Whoa, I don't want to do that. That's, 3,000 meters a second. What is going on here? Oh, I see what's going on. I'm trying to create an equatorial orbit instead of just going into a polar orbit. Whoops. So, this is only going to be about 90 meters a second instead of almost 3,000. But I'm a little worried. Nope, I can still see the sun. That's good. Right on the edge of the horizon there. And the reason for that is because of my altitude. Because this craft is so high above the surface, it's catching sunlight when the surface is not. This is true if you go up on a mountain. Sunrise and sunset is at the top of the mountain is about 2 minutes later than the bottom of the mountain, depending on the height of the mountain, of course. There we go. I'm going to go ahead and stay pointing this way, and I'm going to activate my scanner. Uh-oh. I'm too high. Oh dear. That's not good at all. So, I need to point retrograde. And I'm going to drop my periapsis down to 100 kilometers. So here we go, adjusting down to 100 kilometers. There we go. And now we are going to circularize at our new periapsis. And I'm actually kind of glad that this probe has so much delta V so that I can do that. Where... Still says I'm too high. This is a bit of a problem. I don't know the maximum altitude of this scanner, which is something I can check in the vehicle assembly building. It's not a big deal. But if I'm too high at 100 kilometers, I don't really want to go much lower. So let's go ahead and stop the scan, and then we'll restart it and see if that fixes things. It's going to pack itself away here. Now we're going to restart this scan. Still too high. Alright, so we are going to adjust our periapsis down to 75 kilometers, which is just barely above the atmosphere. I don't like doing that because if something were to go wrong, or, you know, if something were to happen and this spacecraft and another spacecraft are on the same trajectory, there is the potential that they could collide. And if they collide, that would very probably destroy both spacecraft. Also, as you can see, I'm going to run out of power on the dark side of the Earth. So hopefully this is stored in the flight computer and it will execute. No, it will not. Crap. Alright, so we're going to go ahead and cancel that node. And we are going to warp around. We're going to create that. And we're going to execute that node through the flight computer so that hopefully alright, you know what, I'm gonna go back into the vehicle assembly building and see what the maximum altitude for that scanner is, because I might not be able to perform an orbital scan, which doesn't make a whole lot of sense to me, but these things happen. So we'll see what the problem is. Into the vehicle assembly building we go. So, if the maximum altitude is less than 70 kilometers, I'm not going to be able to use a probe, which is going to be quite an issue. Science, here we go. And it is the... So it says maximum altitude is 500 kilometers. Okay. Well, that's good. So, I will boost up to 250 kilometers, and it should still work. I'm going to the tracking station here. We're just going to fly it. We're not going to worry about a maneuver. We're not really going to worry about a whole lot with it. Because it doesn't really matter where our apoapsis and periapsis are in relation to the planet's surface, just that they are at the altitude we want. So, here we go. We're going to point prograde. Go ahead and cancel that maneuver, so we don't need it. Oh, light our engine. There we go. So the maximum altitude is 500 kilometers. So I'm going to go to half that, which is 250 kilometers. So that I have a little bit of margin for error. Circularize this next apoapsis. And because this is going to stay in orbit for a while, it will eventually scan the entire planet. It's just going to take longer because it has a narrower beam. Look at that. That is beautiful. Very serene. Oh, looks like we got a texture line there. But it's alright. Things happen. Looks like I'm gonna pass over Alaska if I had to take a guess. Yep, that's Alaska. Goes boosting its orbit. There we go. So now I should be able rename this. So I included a fuel cell on these satellites just in case I did not have enough power generation with my solar panels. Turns out I don't actually need them. So we are going to rename this vessel, and I'm going to call it Earth Terrain. I'm going to warp. It says I'm too high. Maybe the max altitude is 50 kilometers and it's a typo. That would suck. So, let's see if we can. No. Oh well. We will just let it scan, and if need be, we'll come back to it. Or we'll adjust it later. So, anyway, till next time, I'm Taki117, and remember, it's only rocket science.